Srinivasan from Chemistry Department, IARE. So in this video, we will see desalination, removing of salt, dissolved salt from seawater. That is seawater or brackish water, whatever it is, by reverse osmosis process. So this comes under water technology module. Topic is desalination. So what is desalination? The process of removal of dissolved salts, NaCl, majorly NaCl, KCl, present in water to such an extent it is usable is called desalination, because directly in some places, for example, Kuwait, they are largely using, dependent on conversion of the seawater to the useful drinking water, because the availability of potable water, availability of fresh water is very less. So they are depending on this conversion of seawater to useful water by desalination process. So in Saudi Arabia, they have the biggest desalination unit is there in Saudi Arabia. So in Middle East, in some many places where the availability of seawater is much more, and its availability of normal fresh water is scarce, then in those places it is highly useful desalination process which converts seawater or brackish water into fresh water. So water, before going to the process, how it is done by RO process, water is divided into different categories on the basis of salinity. Salinity means salt, brine water, salt in water. NaCl, salt content in water. Quantity of dissolved salts, basis of salinity, on the basis of quantity of dissolved salt. Fresh water means less than 1000 ppm of dissolved salts, NaCl, KCl. Brackish water means in the range 1000 to 35,000 ppm. It has a peculiar salty taste. Seawater means greater than 35,000 ppm. It is seawater. So seawater and brackish water can be made available as drinking water in many places where the availability of drinking water is very scarce. They use desalination process to convert seawater to the drinking water. So in Kuwait, Saudi Arabia has the largest desalination plant. Okay, like several lakhs and liters of water is separated daily, is desalinated daily, and there is a special technique and special area is separated for that. So there is the whole many places in Saudi Arabia is fetched water from the biggest desalination plant. So desalination process is carried out by the following methods. So normally we say reverse osmosis process. Reverse osmosis process. So famously we called RO process. Okay. There are other obviously natural methods are there. Natural, like evaporation. Water evaporates, then it is condensed, and then it is collected. So these are all normal life cycle. Okay. Special process or RO process, desalination RO process. This is the process used in many places in Kuwait, Saudi Arabia and all. And another process we have electrodialysis. Both these things are membrane, depended on mainly membranes, semi-permeable membranes that are semi-permeable, that it allows the solvent only and not the solute, that is salt. Okay, so by that way they can, through semi-permeable membrane, they can separate the fresh water from the salt water. One side salt water will be collected, and another side, through the semi-permeable membrane, the fresh water will be collected in the other end. Okay, other side of the semi-permeable membrane. So both this RO and electrodialysis are dependent on semi-permeable membranes, membrane technology. Okay. Next. As I told, natural desalination water cycle, major stages in that is evaporation, condensation, precipitation and collection. Okay. So thermal desalination process is there, which is similar to its natural water cycle. Water is heated, evaporated and collected. It produces clean water and brine. Brine is water containing salt water, water containing salt. Clean water means it is can be used for many different domestic purpose and other things, which is having very less salt or usable, in the usable way it is there to such an extent clean. Salt water means it's available obviously in the sea water. Okay. So sea water contains greater than 35,000 ppm of dissolved solids, NaCl, KCl. Brackish water can also be converted. Brackish water we have seen is 1000 to 35,000 ppm. Okay, so thermal desalination process is also possible, which is similar to the water cycle. Natural water is heated, then what happens? Evaporated. Water is evaporated, then it is collected. Okay, then it produces clean water and brine by natural water cycle. This is natural desalination. But we are going to see, which is widely used and popularly in the desalination process, is RO process. Okay, before that, there is example of this thermal desalination process is multi-stage flash desalination. This process uses multiple boiling chambers kept at different atmospheric pressures. Salt water enters the system and it is boiled and evaporated in each chamber. This process produces clean water and brine separately. Example is multi-stage flash desalination. Okay, multi-stage flash desalination. There will be multiple boiling chambers to boil the saline water kept at different atmospheric pressures. Salt water enters the system and is boiled and evaporated in each chambers. This process produces clean water. And so then now comes the famous process, reverse. We talk about reverse osmosis process. Okay. Now we'll talk about RO, reverse osmosis process. So we are very frequent of this word, RO process. In many places, RO process to water followed by UV light. Followed by UV light is passed to kill the germs, all those things. Anything is remaining to ensure. Okay. So this RO process, what is osmosis? Okay. What is reverse osmosis? This RO process is more prevalent in household drinking water system nowadays. It's very handy and also it is very viable to do fresh water, clean water. So all those things are their advantages are many. So this is the widespread. This is widespread in small scale as well as large scale use in water technology. Okay. So we will see more. Next, osmosis. What is osmosis? So what is osmosis? In a system where two solutions which differ in their concentration are separated by a semi-permeable membrane, solvent molecule passes through the membrane from the side having lower solute concentration to the side having higher solute concentration. So here, this is a semi-permeable membrane, for example. Then solvent flows spontaneously from low solute side to high solute side. This spontaneous flow is due to osmotic pressure and concentration gradient. Okay. Now, reverse osmosis means if you apply external pressure greater than this osmotic pressure on the higher solute side, higher solute concentration side, then the flow of solvent reverses from this side to this side, higher solute concentration to lower solute concentration. That's why we call it as reverse osmosis. So osmosis is a spontaneous flow of solvent from lower solute concentration to higher solute concentration, and it depends on the osmotic pressure and concentration gradient. Now, reverse osmosis. What is reverse osmosis? When it is possible? If you apply the external pressure excess of the osmotic pressure on the concentrated side, then the solvent flow is reversed from higher solute concentration side to lower solute concentration side. So that is, solvent is forced to move in the reverse way to osmosis. That's why we call the name reverse osmosis. Okay. Osmotic pressure is a colligative property. What is meant by colligative property? Colligative property is depends, means if a system osmotic pressure depends on the number of solute molecules. Osmotic pressure. So that's why we say it depends on colligative. Colligative properties are the system which depends on the number of solute molecules. We say which depends on the concentration of the solution. In water purification, the reverse osmotic process is very, very important. So what is the principle behind this? Due to the presence of membrane, large molecules of the solute are not able to pass through it, and they remain on the pressurized side. Okay. The pure solvent on the other side is allowed to pass through the membrane. Okay. So when this happens, the molecules of the solute start becoming concentrated on one side, and the other side of the membrane becomes dilute. Okay. So this is how fresh water is separated by desalination process through a membrane which allows only the solvent to pass through and not the solute. So one side becomes totally diluted, another side becomes more concentrated with salt. The membranes used in this process are cellulose acetate, cellulose butyrate, etc. This method is applicable mainly for the desalination of seawater. See, these membranes play a major role. If membrane has to withstand the high pressure, that is sometimes not there. Sometimes with high pressure, the the membranes will not withstand that pressure. Then the system becomes a problem. So that is one of the drawback where membrane technology have to bring more membrane material which can withstand very, very high pressures like that. Okay. So this, if you apply hydrostatic pressure on the seawater, and this is a membrane, semi-permeable membrane, which allows the solvent only and not the solute. If you apply hydrostatic pressure greater than the osmotic pressure, then the water solvent passes through the semi-permeable membrane, and here solute will be stable. So what happens here? This is dilute, this is more concentrated of salt. So thereby, this is the outlet of pure water. Pure water is separated from seawater. Okay. And another, so at present, another disadvantage, not a disadvantage, one of the condition for this is they won't come for a long time. The membranes have to be replaced, not very often, but once in 2 years or so. So this is good in terms of converting brackish water and desalination of seawater to some extent. To the higher level, the pressure, the very important thing is the membrane should withstand the pressure. That is the important point in this desalination, reverse osmosis principle. Okay. Okay. Reverse osmosis is a membrane treatment process primarily used to separate dissolved solutes from water. Dissolved solutes from water. Reverse osmosis is a membrane treatment process primarily used to separate dissolved solutes from the water. It's most commonly, RO is most commonly known for its use in drinking water purification, particularly with regard to removing salt and other effluent materials from water molecules. Okay, so it is known for its use in drinking water, particularly with regard to removing salt and other effluent materials from water molecules. So if you want to remove this type of effluent, any impurities and salt, then this process is highly useful. It is important to note that the pressure applied to the solution side must be higher than the osmotic pressure for the reverse osmotic process to proceed. Okay. So we know that the osmosis process, in osmosis, the movement depends on the osmotic pressure and the concentration of the water, concentration of solute in the water. But in order to reverse it, you have to apply pressure applied to the solution side must be higher than the osmotic pressure of the solution applied on the higher solute concentration side should be more than the osmotic pressure of the system. Okay. Then only reverse osmosis occur from solvent moving from higher concentration side to lower concentration of solute, lower solute concentration side. Many water purifiers today use RO in the purification process as one of the steps. So it is more prevalent in usage for the purification process of drinking water. In almost all houses we have, many places we have RO system. Okay, you can see it's more it's more prevalent in use. Advantages. Available units are relatively compact and require little space. Process is simple and continuous. The process needs low energy. It's not a higher energy consumption one. In average use, the membrane has a life of little more than 1 to 2 years before replacement is necessary. It's okay. It's not that much bad. Periodic complete sterilization of the RO system with formalin or other sterilant is practical. Okay. We can periodically sterilate the RO system with formalin or other sterilant is also practical. Disadvantages mean cellulose acetate membranes have limited pH tolerance. They degrade at greater than 90 or 35. Greater than 35 means what temperature? Maybe you can keep 60 or around 50 to 60. And particularly pH tolerance, limited pH tolerance, highly acidic, highly basic. So water should be more or less uh, near to the they should not be highly acidic, extreme acidic or extreme alkaline should not be there. They have pH tolerance. So membranes will go bad or membranes will not properly function in the extreme conditions. The process is successful only for the recovery of fresh water from brackish water. Okay. It's not like that. RO in large scale, people have started used in conversion of seawater for seawater to pure water conversion. So I am not very sure about this, but successful only no. Successful for the recovery, not only. It is successful for the recovery of fresh water from brackish water and also successful in seawater to pure water. Okay, because it is practically done in many Middle East places, Middle East countries. Of course, the technology they are using is very, very sophisticated and high end, but normal in the lower level of what units we use in the home, maybe we are doing it fresh water from a little bit less brackish water. Okay. Okay. So this is one famous method. And just to mention about the other method also, that is called electrodialysis. So dialysis means separating the water, seawater into fresh water and fresh and salty. Okay. So obviously here electricity is used in electrodialysis. So, but here we have anion permeable membrane and cation permeable membrane. So NaCl in water. If you apply current, if you apply electric current or potential, what happens? Na plus and Cl minus ions. So they will be having a big bath like this, where this seawater will be there. Okay. In this we have different membranes. This is seawater. So different membranes are alternatively placed. Okay. So C means cation permeable, anion permeable, cation permeable, anion permeable, cation permeable, anion permeable, cation permeable, anion permeable membrane. Like that it is arranged. So now what happens? This NaCl here, Na will go to here, Cl minus will go to here. So similarly, Na will go to here, Cl minus will be here. From here again, Na goes here, Cl minus, okay, sorry, here. Cl minus will go here. Similarly, from here, Na goes here and Cl minus goes here. Now, this, if you connect this end in between this membranes and if you connect the membrane side, so this one side will have very less salty, and this is more salty, more concentration, means more salty concentration. So if you in between, this is very less salt concentration because it is split into Na plus and it is attracted towards anion permeable and cation permeable. The other one will be having more salty concentration. Thereby, we are separating the fresh water from the salty water. So this is also, but you need electricity for this. You have to apply potential for this. Then it will goes like this, permeable. So permeable means then you can collect it from here, right? Okay. So permeable, Na plus will go to cation, Cl minus will go to anion. So the water in between these two will be having less NaCl. So if you can collect all these things from this membranes through this, we get more. In between, if you connect and then you get very less salt concentration. Okay. There is some principle like this. Okay. With this, we will finish this desalination process video. We will continue in the next video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.